Okay, hi everyone. Today should be Thursday, January 3rd. Okay, so this is the aim for today. What real-life applications does the Pythagorean theorem have? So I'll give you a minute to get that copied. This is just a continuation, really, of yesterday. And again, you can watch this video anytime you want, at your own pace. And just a reminder, you do need to know the Pythagorean theorem for the final, which is on January 11th. Okay, so how do we know when to use the Pythagorean theorem? Okay, so that's what we're going to talk about first. Okay, so first of all, you can only use the Pythagorean theorem if it is a right triangle. Okay, so right triangles only, write it down. It can only be used for that. Okay, and we use it when we know two sides and want a third side. Okay, that's how you know when to use the Pythagorean theorem, when you have two sides of a right triangle and you want to know the third side. Okay, I hope you're copying this down. Okay, so let's move on and let's look at it like a real-life example. So I know this just looks like a right triangle to you, but I could also say that this is a building over here. So there's a building right here, and this is the ground right here. Okay, so I'm going to use B for the building and G for the ground. And when you think about a building you think of as a vertical line, and when it meets the ground, which is a horizontal line, that would have to be perpendicular, and therefore you have a right angle. And I'm just going to call this side over here H for hypotenuse, okay? So let's say that there is a 15-foot ladder leaning against a building. Well, H would have to be our ladder. So I'm going to erase H, and I'm going to put 15 there. Okay, so this is actually our ladder leaning against the building. Now there's a top of the ladder, that's up here, and then there's a foot of the ladder, and that's down here. The foot of the ladder is 5 feet from the base of the building. This is the base of the building. So therefore, we know that G must be 5. Okay, so we have a 15-foot ladder. The foot of the ladder, that's right here, is 5 feet from the base of the building, that's right here. So how high up on the wall does the ladder reach? So how high would this point be up here? So what we need to do is we need to find this length right here, okay? Because we want to know how high is the ladder reaching. Okay, so the most important thing is you want to find the hypotenuse first, and the hypotenuse is always located across from the right angle, so 15 is our hypotenuse. Okay, and now we're ready to substitute into a squared plus b squared equals c squared. So I would recommend always putting in the hypotenuse first, so you just don't screw that up. And then the other legs go over here. And it doesn't matter which leg you put in first, because when you add, it doesn't matter if you have 2 plus 3 or 3 plus 2. Okay, so I'm going to give you a minute, see if you can figure out what b is. Put this on pause, try and solve for b, and then when you guys are ready, then just come back and see if you got the correct answer. Okay, so here's the solution, and I got that b equals radical 200. So there are different ways that you could be asked for an answer. You could just gotten it as b equals radical 200, or you may be asked to round that to the nearest tenth. So I'm just going to go to the next page. So at b equals radical 200, if you put radical 200 into your calculator, you should get this. And so if you're asked to round to the nearest tenth, that would be up to here, and then you would say that b equals 14.1. Remember, when you're looking to round to the nearest tenth, you really go to the hundredths place. And if it's 5 or greater, then the 1 would move up to a 2, and if it's less than 5, it just stays 1. Okay, but what's something else that you could be asked? Well, let me go back. What if you were asked to write this in simplest radical form? So we just recently learned how to simplify radicals, so we could break this up into 102. and then we would get 10 radical 2. So that could possibly be an answer as well. Okay, here's another word problem example. So I'll give you a minute to copy this story down. And we're talking about Tim, and he's riding a motorcycle, a bicycle, I don't know what Tim's riding, but he's riding 8 miles north, then 3 miles east. And we want to know how far did he travel. Okay, so just don't forget, this is north, south, east, and west. So you can press pause if you want while everyone copies the problem, and then when you're done, just come back. Okay, so let's say that Tim starts right here. Here's Tim. And first he's going to go 8 miles north, which means he went up this way, and he went 8 miles north until he got to that point. Once he got to that point, he went 3 miles east. So he went this way 3 miles until he got to that point. And the question is, how far did he travel? So we're looking for this orange line right there. Okay, so we're just going to call that x. So if I travel north and then I travel east, I'm going vertical and then horizontal, and then therefore those lines are perpendicular, and there's my right angle. So I look across from it and I see that x represents my hypotenuse. So I'm going to get 8 squared plus 3 squared equals x squared. 64 plus 9 equals x squared. 73 equals x squared, and I know 73 is not a perfect square, so I need to be prepared for simplifying a radical or using my calculator. And I'm going to get x equals the square root of 73. So if you put that into your calculator, you would get that x equals 8.544, and it continues on. And if you were asked how many miles did he travel, then you're going, that means a whole number. We're going to round it, and since 5, remember I said if it's 5 or higher, it goes to the next number. So we would say Tim traveled 9 miles. Okay, and that would be the answer. And so how would you know to keep it in radical form or to round it? It will tell you. The question will say round to the nearest tenth in whole numbers, like in whole miles. Otherwise, you're just going to leave it in terms of a radical. It doesn't say to round or anything like that. You just leave it in terms of a radical. Okay, so let's just summarize here. Okay, so remember the Pythagorean theorem can only be used on right triangles. So everything we're doing now is just for right triangles. Okay, we're going, so let me just make little bullet points here. We're going to use the Pythagorean theorem when we know 2 sides and you want a third side. Okay, if you're not given a picture, always draw the diagram. And then always check to see if it, not if, let me just change that, to see if the answer should be rounded or left in radical form. Okay, and then I just want to point out 2 interesting things, and then we'll wrap it up for the day. If you need more time to copy this, press pause and then come back. Okay, so there's one exception to when you have to have 2 sides, and that would be if you had an isosceles right triangle. So let's say that you're told that you have an isosceles right triangle. So this is your hypotenuse over here. Whoops. now one thing I think that I did not mention that's really important is that the hypotenuse, so let's write this down, hypotenuse is always, and always, I mean always, the longest side of a right triangle. So if you're told that you're given an isosceles right triangle, it means that the two legs must be congruent. It can't possibly be the hypotenuse because that's always the longest one. So let's say that you have an isosceles right triangle and you're given that the hypotenuse is, I don't know, I'll just say 10. Well, if we call this side A and this side B, isn't A and B really the same thing? Because it's isosceles, and that means that the two sides are equal, so we can call them both A. And then we would get, I'm going to make a little box here, A squared plus A squared equals 10 squared. Well, 1A squared plus 1A squared is 2A squared equals 100. If you divide both sides by 2, you get A squared equals 50. And therefore, A equals the square root of 50. Okay, and if you needed to round that, you could. Or you could simplify that because 25 is a perfect square that goes into 50. Okay, so that's really a time when you really did not need to know two sides in order to use the Pythagorean theorem. Okay, and just an interesting little story. So a lot of you always say, why do I need to know this? And so there was a lawyer who knew this, and this is an interesting story. It was in the New York Times in 2005. And here was the story. So this was a school. The name of the school was Holy Cross, not the Holy Cross that's in Flushing. And that was the school. And then if you walked this way, 490 feet, and then down this way, 764 feet, right here is where there was a drug dealer selling drugs. So there was a drug bust right here. And there's actually a law that says that if you deal drugs within 1,000 feet of a school, the penalties are much higher, like you'd spend more time in jail than if you were further away than 1,000 feet from a school. And so so if you go this way, that was 490, and then down this way, which is 764, you get 1,254 feet. And so the defense was trying to say, but the drug dealer shouldn't have the penalties because he was over 1,000 feet away from the school. But this is where the prosecutor was happy, probably, that she paid attention in math class, because she said, no, that's not how you measure distance. You measure distance from point to point. And she used the Pythagorean theorem to say that they should be using the length of this orange line, and she did 490 squared plus 764 squared to get the hypotenuse squared. And it turned out that the distance, I'll give you these numbers in case you're interested, was actually 907.63 feet away, and then the guy got double time for selling the drugs. So I just thought that is definitely a real-life example and very interesting why you need to know math in all aspects. So that wraps up this lesson, and I hope you now know everything you need to know about the Pythagorean theorem.